Well, hi, good morning. Thanks for joining me in my shop here. It's the 4th day of August, and I think this might be the last day here for this radio. I'm not so sure what I can do with it at this point to improve its operation, other than one last alignment effort, which I will be doing shortly, and I may not put on video. I may just do it, and then a late in the evening shortwave run around with an antenna just to make sure everything's working good. C-band still weak. Hey, the C-band is still weak. Maybe I could look into that. Yeah, why don't I make that my topic today? Weak C-band. What can I do about that? But before I do that, I just came from watching a bit of TV, of course, before coming in the shop here. Let me tell you what I was watching on TV. I was watching an interviewer interviewing UFO investigators. Now, I did my UFO investigation when I was a kid, read a couple of books, thought about it pretty hard, and reached the conclusion, no, there's no UFOs from other planets coming here. But anyway, he goes to see this woman who's totally convinced. She's been a UFO investigator for 40 years. 40 years of UFO investigating. She runs a little outfit where people come and she takes them out into the desert. She lives somewhere in Arizona or something like that. At night, with a very beautiful clear sky, and they look up in the sky and they can literally count the UFOs. So he thought this was something he needed to look into. So he went down, he interviewed this woman, and then the next scene, they're out at night, sitting in lawn chairs somewhere, looking up at the sky, waiting for these UFOs. And she guarantees him, UFOs are coming. Every night she sees them. Sure enough, she says, look up there. And the camera looks up in the sky, and what I see is a satellite moving through the sky. The interviewer says, isn't that a satellite? And she says, it can't be a satellite. They don't have lights on board. 40 years of investigation. And there you are. So my decision at 8 that there's no aliens running around the planet, no secret technology hidden by governments, none of that stuff. Area 51 isn't all that much more interesting than other areas of the world, remains the same. Okay. I live in a UFO-free world. Good for me. Okay, so Band C. Band C. I think the only approach, the initial approach anyway, for trying to figure out what's going on with Band C is to figure out what's different about Band C. Well, Band C is quite different. Of course, Band C covers a large range of frequencies. In fact, Band C here contains these other bands. These are all inside here. Like the 9 megahertz band is right in here. Right? The 11 megahertz band is just below the pointer. And the 19 meter band, 15 megahertz band, is up around here. But on this band, you get everything in between, and not normally sideways. C-band. Okay, so I guess the way to do this then is to look at the schematic and try to figure out what it is that is singular about the C-band that could be the cause of weakness that's different from the other bands. Okay, I'll give that a shot. Okay, so I've been studying the schematic here for a little bit, and I am not hopeful at all that I can even understand this properly. So the band involved is the C-band. The C-band oscillator coil is here. I just realized I've studied the oscillator side of things. I haven't really looked at the rest of the radio, but let's just carry on here. In this, the schematic is shown as if the radio is operating in AM. So this coil should not be active. The broadcast coil is this one down here that should be active. So the wires coming out of here are probably going nowhere. So we trace them down, and I'm not going to spend too much time here. They really are right here. These two. Open switch. Yeah, massive capacitors. And the other wire, open switch. So of course it's in AM mode, so these switches are open. frankly, for me to sort all this out and to understand what all these capacitors are doing and who's hooked up to who and when the switch is there, what's, where's things flowing and all that, it's too much for me, considering the situation here and the fact that I could do all that and band C remains low. Right? Anyway, you're not going to hear too much on band C that you wouldn't hear on those other bands. Anyhow, a little bit, but not too much. And we know that a strong signal can come through on band C. I'm justifying leaving it alone here. One thing I did notice, let's just look at this batch of capacitors down here. In my experience, your typical capacitors plus or minus 20%, and a better one is 10, and a really good one is 5. Look, here's one that's 5%, which means the value that the manufacturer is claiming is within 5% of the truth. Well, look at these, 2.5%. Yeah. What? You want to go outside? What's the story, Black Cat? I'll have to deal with her in a moment. So here's the thing about this. I don't have 2.5% accurate capacitors. But more importantly, what are the chances that these are still within 2.5%? The engineers and designers picked these very, very accurate capacitors for a reason. They can't tolerate being out of range. A lot of other capacitors, though, they could be half, they could be double. You're not going to make much difference. 2.5%? I don't think they come any better. I don't, to buy a capacitor back then in 1940, say at 1%, you probably couldn't buy it. You probably couldn't make it. So this radio is built with the most precise capacitors around, and here we are, 60 years later. Why do you do this? For some reason, this piece of software just does this regularly. There's nothing to show here. Well, perhaps that's my point. There is nothing to show here. Yeah. So now, part I didn't look at all this stuff over here. Good luck to me again. But let's take a look at it. So here's the band C up here. I'm gonna guess, and it's a guess, that when band C is operating, this wire is operating. This outside one's always on. You know what? I am not gonna be able to sort this out. Yikes! Yikes! And then right into a switch. Sort it out in the hopes of finding something that can be fixed or adjusted or changed. My only hope really is alignment. There's one remote possibility here, and that is it's not so remote. The alignment is incorrect on that band. The local oscillator is on the wrong side of the target frequency. That's really a more likely scenario. Maybe I get into the alignment process with this radio, and that'll drag me right through that issue about where the local oscillator is, and maybe I can deal with it then, or maybe I can jump right to that. Why not jump right to that? Well, I can say hello, good morning again, because it's actually the next day. I left my shop there and just never got back in here yesterday till now. So it's the next day. It's now August 5th. And the last thing I was saying was, why is the C-band weak? And I got scared by all the capacitors I saw on the radio, very precision type capacitors. And then I thought, wait a minute, there's another possibility here. Perhaps the local oscillator is on the wrong side of the target frequency on this band. And that would explain its poor performance to some degree. So that's what I want to experiment with today. I think I took a look at this. Maybe earlier on, I can't remember. I do too many radios to remember everything. So we're going to start again. So I'm going to determine where the local oscillator is here. Remember, we have a target frequency where the radio is tuned, and you have a local oscillator that you're varying the control. And whenever the separation is 460 kilohertz between the local oscillator, actually more like that, between the local oscillator and the target frequency will come out. And see, that occurs twice. You have a local oscillator above or the local oscillator below, you get the same 460 kilohertz separation. This will come out. The difference is the rest of the radio is tuned or peaked up for either here or here. So if you do this wrong, if you put it in the wrong place, yeah, you can make adjustments, and you can get peaks going and all that kind of stuff, but the overall performance will fall below where it would be if you got it on the right side. And how much of a difference to make? Not a huge amount of difference, I think, with a band that's covering, this is covering 12 megacycles here, so it may not be all and end all influence, but let's check it anyway. So I need to warm everything up here, and do it that way. So we're going to stop and just warm up everything. Okay, first step here is to compare to this chart I made up earlier. The shortwave band at 10 megahertz, it was requiring 100,000 microvolts of input on the antenna from the signal generator to generate a level on the meter here, like you see now. So this is 6, close to 7 volts. That's kind of where I was doing all this. So currently I am feeding in a signal sufficient to get the AVC voltage up there. Let's just make sure the radio's very tricky to tune this high band. Okay, 7 volts, and the input power, I've calibrated my signal generator. I don't have to worry about this right now. So it's 10 times 1000, that's 10,000. 10,000 microvolts to get the effect, and here the last time it was 100,000 microvolts. So somewhere along the line I've managed to make this band 10 times as sensitive. But other bands are doing that with around 1,000 microvolts, even less. So I'll set this to 1,000 microvolts. That would be there. Now we see on the meter, when other bands can make this meter come all the way up to 6 or 7 on this band, it's low. It's not as bad as it was, though. Very good. Okay, so to determine where the local oscillator is, I need to figure out the frequency of it. I'm going to use my SDR radio to do that. I'll get that stuff set up, and we'll continue to let things warm up here a little bit, and hopefully this guy will come back to life. Come back to life. Looks like another repair coming here. Okay, here we go. So this radio is tuned to 10 megahertz. Signal generator is running at 10 megahertz, which is why we can hear it. Signal generator signal is 1,000 microvolts. That's a moderate signal on a fairly decent antenna, I guess you could say. So, again, maybe I'm chasing some smoke here. This is not working all that poorly. Okay, now we'll look on the SDR and we'll figure out, relative to 10 megahertz, where is the local oscillator. So I'll flip the SDR up on the screen here. So here we are. Got the red line, or the tuning line for the SDR, set on 10 megahertz. Well, almost set on 10. There we are, 10. And so this is where the radio's tuned. So the local oscillator in the radio should be 460, almost 500 kilohertz away. So we can go up in this range. There's nothing up here. And we can go down in this range, and look at that. So that's got to be the local oscillator right there. That great big thing. What's this? I don't know. What's this thing? I don't know. What are these other things? I don't know what they are. But this I'm sure is the local oscillator. It will tune the radio upwards, and that should move that up also. See, it jumped up. It jumped up quite a ways. Let me tune this really slowly, because so I'm turning the tuning knob on the old radio. A lot of strange patterns on here. Yeah, but the main one I pointed out is the local oscillator. Has to be, because of the 460 kilohertz difference. These other things, I don't know. especially this one over here. This one's appeared. Look at this gigantic signal. I'm going to turn off the radio and we'll just see how many of these signals are coming out of the radio. So here we go. I'll turn it back on. Okie dokie. Yeah, what is going on with this? Why are there two of them here? If you had two local oscillators operating in this radio, the radio could potentially tune two different things at once. You sent two local oscillator frequencies into the mixer tube, whatever's 460 away from either one. You could actually have 4 signals received with 2 local oscillators. Now, let me turn again. I'm going to tune upwards. I think. Let's just double check here. Okay, it's still on 10 megahertz, so it's still 500 below. Oh my gosh, really? 500, 460. What's this here? Silence ensues. That's a lot. Maybe I tune this rate to 10 because it's, according to the dial, you know, the radio's not 100%. So even though it says 10 on the dial where I have it tuned now. Okay, now we can count down 460, which would be 540. Yeah, radio. There it is right there. That's a local oscillator. Okay, well, and it's gigantic compared to the other signals. Now I'm going to tune upwards very slowly. So isn't that strange, eh? So the one to the right of the local oscillator is going down, and they're all going to join forces right at this point here. Someday I will figure out what is really happening in these radios, and I believe this is the result of the mixer tube and its actions. But and I see this all the time on radios when I do this. I really can't fully analyze it, and don't care to right now. So clearly the local oscillator is below the target frequency. Now I want to move this. I want to recalibrate the radio, move this up. When I do that, on this band there's 2 other things that need to be tuned up also to match it. Yikes. Yikes. Okay, well we'll have to do it to do this experiment. So assumably the radio is properly aligned with the local oscillator below. I'm going to shift it up above and then perform that alignment, and we'll see if our sensitivity doesn't go up. Now I may be barking up the wrong tree here because the 31 meter band is tied in with setting the alignment of this band too. So. But there is a separate alignment adjustment for this band. Oh, I just can't imagine it's got the range to move that local oscillator all the way up to here. Let us give it a go. Okay, so I'm going to leave. So there's 2 adjustments to change the local oscillator on here. The one I would tend to use will also change it on this band. But this band's working good. I don't want to move it. So we'll just try the other adjustment. Good luck on this. And we need to have the SDR up on the screen here. Okay, local oscillator movement. This adjustment is really supposed to be done at 17 megahertz, but I'm going to do it here and just see how far we can move it. Okay, I'm moving it. Well, if I open this way up, just about the limit of the adjustment. So to make this work, this has to be up here at right around here. I'm putting the red line there. And I can't get there. Not with this one adjustment. That's as far as I can go. Right on top of the 10. Okay. I'll put it back here. I guess you could say the in these radios, the mixer really mixes everything up. Okay, we have to get this back on 10 exactly. 10. Wait a minute. Not with the local oscillator the way it is. Yikes. Okay, a little bit of a mistake here on my part. That's okay. Not the end of the world. So we want to be, let me put the red line there. We're tuned to 10 megahertz, and we want this to be at 9540. That's it, 9540. Oh, it's right on. Is that the local oscillator, or is that some other thing? That's it. Got it. Something's not adding up here. Okay, radio's tuned to the signal generator. Okay, signal generator is set to exactly 10. It's a little off. Right on 10 now. The dial looking right at number 10. I don't think we're going to get anywhere here. Unless somehow the 31 meter band has been done backwards also. I don't think the chances of that are too good. Let's go there. See, it's got loads of that. Loads of that. Let me tune the radio a bit. You know, when I do this with the SDR and I look at these things, these signals are way out of the important. No, they're not actually. They're not. Okay. Tuned to 9.5 on the 31 meter band. Checking. Okay, it's right on the money. Okay, we can produce 7 to 8 volts of AVC with 1,000. With 1,000. Yep, with 1,000. So we're back to exactly. So this is. It's yeah, a lot of What are you doing, chum? I don't really know. Okay, so when I look at the chart here, that was a 31 meter band, 150 microvolts. It's super sensitive. To produce the 7 volts of ABC. But now, what am I doing wrong? So I have 100 times 10 to 1,000. So that's 1,000 there. Well, what if I knock this down? You can see the voltmeter over here now is dropped below the target range, not by much. Tune the radio a bit. No. Maybe I made an error last time around and I wrote down 150 when it should have been something else. Curious. A very, very good radio is sensitive down to a few microvolts. So we're far, far from there. But this is the way I'm doing it. When I say sensitive, that means a few microvolts and you can start listening to maybe somebody talking, something like that. We're not doing that here. And that's not the kind of test we're doing here. Am I getting anywhere? I think the short answer is no, not really. The only other curiosity here would be this adjustment is way high compared to the others, and that can mean nothing at all. That's just the way it worked out. But it could also mean something. So that's the, you know what, that's the 31 meter band. That's the 31 meter band, he says. So just so you're clear, I'm noticing that all these are down. Well, this one's up quite a ways. Like I'm saying, that doesn't necessarily mean anything. By the way, this is the SDR pickup coil here. It's just a clip lead, just a clip clipped around the mixer tube to pick up the local oscillator signal. It could be why it's picking up so much else, too. Well, let's look at where the local oscillator is on the 31 meter band. So we're at 9.5, and I'm just lost here. Okay, here we go. So local oscillator way up here. This powerful signal. That'd be 10.7. If you subtract 400 from that, you get 10.3. The radio is tuned to 9.5. What happened here? What? No, wait, look at this monster down here just off the screen. This thing. This has got to be the local oscillator. And it's a blasting signal. Okay, so if that's a local oscillator, you notice it's below 9. So if you add 460 to 9030, you get 9.5. That's where it's tuned. Local oscillator's below, and this band's working great. Okay, so you know what I'm gonna do? I'm gonna move that adjustment down into a position which is similar to the others. And we'll watch the local oscillator and see if it doesn't end up if the adjustment doesn't end up at the same level as the others. Okay, so first off, as I turn the adjustment in the direction I want to go, the local oscillator is actually going the wrong way. It's actually getting worse. I'll come back. Do a little alignment work here. Okay, just one sec. I'm just going to set the signal generator exactly 9.5. I'm watching the indicating meter. Get all the way up to 7.5 volts. There we are. Am I getting anywhere with this? No, I'm not getting anywhere at all. I'm not in any way proving the local oscillator's in the wrong place. Maybe the bottom line on this radio is, you know what, that's as good as this is going to get. Maybe because it's broadband, it can't be as sensitive for some reason. Maybe that's an element of it. Maybe when you narrow band these things, when you spread band, that's the proper term for them. Maybe you can get a lot more sensitivity into them. Not sure. Okay, another little experiment here that's worth doing, just kind of for fun, is image frequency. Image. Let's do it that way. So we'll tune here to 10 megahertz. Okay, so we're on 10. And we'll set the signal generator to 10, and we should hear it come out of the speaker. There you are. The little difference in number here is just a little difference in tuning of the radio, just fractional differences. Now, if the local oscillator is below, if we go another 460 below that, we'll probably hear that signal generator on this radio again without retuning the radio. The radio stays on 10. Turn this down close to 9.1. See what we hear. We can't get there. That was interesting. That's interesting. Little pops. Here we come. I didn't hear it. So what we're checking is the ability of the radio to suppress an image signal. A signal sitting on the other side of the local oscillator frequency from the one you're really targeting. That's pretty weak. That's good. That's very good. These other bands on this radio, you can't do this test because they are spread band and it doesn't apply. 4, 3, yeah, it doesn't apply. Very good. I think maybe I've hit the end of the road here with this radio. I can't seem to squeak any more out of it. The only real thing that would be left to do is to tune in some real radio stations. Do it in the evening to see how well it works. But I'm sure it's going to work really well. I think I've hit the end of the road. So I've got the glass here to clean up a little bit. That's not bad. Magic eye to position and put in place. And I think I'm done. Well, I get to say good morning again because it's another couple days have gone by. It's now August 7th, and my plan to listen to shortwave, real shortwave with this radio, maybe compare it to another, it's kind of flopped for two reasons. One is shortwave not very good these days. It's we're in a bit of a weak period, and secondly, I keep forgetting. So what am I going to do? So I think, early on before doing alignment and stuff like that, I did this chart. I thought I'm going to redo this chart now using the signal generator, and I'll compare the results to what I had at first, and that'll also verify the pointer accuracy, which I discovered was certainly a little out on one of these bands. And after doing that, maybe a little bit of alignment work, and maybe then I'm done. I've cleaned up the glass. Well, the glass was pretty clean on this radio, and you can't get in behind it because it's pushed up tight against the backing felt. There's no gap back there. But it looks very good. Very good. On this radio, like some radios, there is paint on the front. It's not all on the back. Like these letters are on the front. This line here is on the front. And these numbers are on the front. And I think maybe there's something on the back too. Maybe that helps give them the that lighting effect you get from the bulbs. I'm not sure. But very, very rugged stuff. These particular dial plates. I have had dial plates where you just touch the print, it comes off. You can't do a thing with it. So I'm always anxious about that. Great. So I'm going to go ahead, work away at the sensitivity analysis, and then we'll see what that amounts to at the end. Okay, I've finished performing the sensitivity check across all the bands here. Some interesting things. The C band remains fairly insensitive. A little better in the middle now. A little better in the middle. Also, the C band is squeezed this way anyway. So 6, which should be here, is actually coming in a little higher. And that's not so bad because the shortwave band for the 6 megahertz area extends down off the scale here. So by having everything move forward, you're going to get a little more. Because there is stuff down here to pick up, which maybe if the radio were tuned properly, it wouldn't reach it. So despite the fact that it's not quite right, this is not a precision band anyway, and it's got problems. Its sensitivity remains low. 100,000 microvolts to generate a straight up indication on my meter over there. ADC voltage. So C-band, not so good. The rest, pretty darn good. So I think when I first did the 31 meter band, I wrote 150 microvolts. I should have written 100. I should have written 1500 there. Now it's 1,000. You'll see 1,000 is just a recurring number in here. Hey, how come I didn't? Oh yeah, this is the broadcast band. I didn't do that. So 1,000. The pointer very accurate. 9.5, very accurate. So that's good. 31 meter band good, same thing up here, 25 meter band, dial's accurate, and sensitivity is about 1,000 microvolts. That doesn't mean it takes 1,000 microvolts to hear something out of the speaker. It takes 1,000 microvolts under this test setup to drive this meter up to 6 or 7 volts. That's what it really means. I'm sure you can hear down to, well, I don't know. Interesting question. probably down to the limits of the antenna. So the antenna is providing noise and signal to the radio. And some antennas provide more noise and less signal. Other antennas do the opposite. Position of the antenna is really important. Is it near any noise-making stuff? So there's all kinds of variations in here. So if you had a noiseless antenna or a very quiet antenna and a powerful one that's tuned nicely, I'll bet you this radio is sensitive down to 5 microvolts. Not to say you could listen at 5 microvolts. It might take 25. I don't really know for sure, but something like that. I guess what I'm trying to say is the radio will operate within the limits of the antenna. You can't do any better than that. Okay, fantastic. And so up here on the top band, we got a big improvement. My sensitivity measurement before, it took 5,000 microvolts of signal to get the voltmeter to come up. And now it's only taking about 1,500. And up here, 1,000. And here, 1,000. So this band is much better off after the alignment than it was. Meanwhile, I was able to watch the Magic Eye, which is operating right here in the middle. Kind of a strange place to put the Magic Eye, isn't it? But then again, it's not. It's right on the chassis. It's not taking up its own real estate, so it's not sitting up here and requiring a bigger chassis to position it up here. It's not separated and bolted into the back of the radio. It's radio cabinet. It's right on here. Where else could you put it? And if you put it dead center like this, well, this is when you're tuning. This is where your eye is. Your eye's watching the pointer and the numbers, and you can see this. So it makes a fair bit of sense to put it right in the middle there. As odd as it is to me, I would prefer it to be kind of off to the side or something, but that's why it's in the middle. All these push buttons here, these are simply mechanical push buttons that mechanically move the tuning, as we saw earlier. There's nothing in them really to tune. The owner himself can loosen off the lock, tune in the station, push this in. The little horseshoe piece will change its angle appropriately. Make sure the radio's tuned in good. Lock the screw again, and there you are. Whenever you push that button, the tuning will return. Wow! That's a pretty good button. This kind of button arrangement, as you can see, the dial spins. I worked on a radio feverishly that had a mechanism so that when you push the button, the dial wouldn't spin. The knob wouldn't spin, rather. The knob wouldn't spin. The mechanism is a big problem. So who knows what these are actually tuned to? Well, I guess we can read. We could guess their broadcast. 1, 2, 3, 4, 5, 6, 7, 8 of them. 8! It's like having 8 memories in the radio. How you access these screws when the cabinet's in place? I don't know for sure. Perhaps you remove the button and the screw is revealed right from the front. So I can't imagine they expected to take the whole chassis out, do this, and then put the chassis back in. That wouldn't go over. So there must be some way to get at this screw from the front. Maybe there's even a panel or something. I don't know. I didn't see the cabinet. I don't have the cabinet. There we go. And let's just check. Phonograph light. Very good. Hey, that's one more thing. I should hook up Bluetooth on this, just to be sure. That's a good idea, Jim. Let's do that. First thing I want to do, though, is check to be sure there's no voltage back there. And there it is. Thought I'd wandered off. Now, I don't expect there to be any voltage, but before I plug in my Bluetooth. So there's a phono input on the back here. Let's go around. I don't think I can spin this all the way around here. Trying to do this from outside. So DC-Y is a big 0. Okay. So I'm going to plug a Bluetooth receiver in there. We're going to see what happens. Okay, this may cause interference on the So there's Jeff Beck, one of my favorite guitars. The guy just has a style like no one else. And I'm going to turn up the volume now. Let me put this over here so my phone doesn't cause direct interference. I have this on phono. I have the Bluetooth plugged into the phono input using a stereo to mono cable. And hear what it sounds like. Watch out for a copyright hit on this. Yeah, he does some weird things with the guitar. Da 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 do do do. Wonderful guitarist. Doing his own thing. Okay, well, there we go. So that's an example of Bluetooth operating with the radio. So it's just a matter of plugging it in to the back, switching this to phono, presto. You've got an instant jukebox through your telephone or tablet or whatever it is you're using with Bluetooth. So that's it. We're done. This radio I deem finished. Although, as usual, after the video's all done and everything's said and done, I usually come up with one or two more things that I need to do to it. But I don't think that's going to be the case here. So fantastic. Of course, we can't really hear what this sounds like. The speaker has to be in its cabinet to really, sound its fullness. But I'm sure it will. Fantastic. Well, that's great. Next radio is here, waiting to go in my shop. In the meantime, I have a couple of odd personal projects I'm probably going to want to diddle around with here in the shop. I may make a video or two. One of them is trying to get my Commodore 64 computer going again. Yeah. Okay, well, thanks so much for watching the series. And again, sorry I can't put this back in its cabinet and we take a final look at what it really looks like, because I don't have it. But fantastic. Wonderful. Very happy. Okay, well, for the last time, thanks a lot for watching. How many times are you going to say that? I'm happy because I'm finished. I'm happy. See ya.